let's do an example. Carlota is designing an archway of a building. The archway should be approximately triangular, but with a rounded top part defined by a parabola. So it's mostly triangular, but if you really zoomed in, you would realize it's not an actual point up here, but in fact a parabola. She has sketched the design as shown. The line segments AB and CD are straight lines, so these parts are not part of the parabola. They are in fact just a line with a constant slope. While the curve above, which starts at B, which is 0.26, and D, which is 0.66, will be a parabola. So between here and here, we have a parabola. It says that the overall height of the archway is unknown, so while it looks like it's at 9, it might not actually be at 9, so you can't make that assumption. The archway is symmetric at the line x equals 4, which means that's our axis of symmetry. It says write down the gradient of the line segment AB. A goes through 0, 0. B, as it says up here, is the 0.26. Go ahead and find the slope for me between A and B. That'll be 6 minus 0 over 2 minus 0, which gives us a slope of 3. So what that means is all along here we have a slope of 3. From A to B, we have a slope of 3. That means at point B, we also have a slope of 3, which is important to keep in mind later. It says write down the gradient of the curve at the maximum point of the archway. Maximum point of the archway is when the derivative, in other words, our slope equals 0. So the gradient of the curve at that point would be 0. Quick. Notice that write down problems are quick. Those should be an indication to you in a test that oh, this should be a pretty simple answer. This should be a pretty simple process. And if it's not, then I'm overthinking it. All right. So it says, given that the parabolic curve is modeled by the function, and then it doesn't give us anything. It's just hey, this is a parabola. We need to solve for all of our coefficients, assuming that the gradient of f of x must be equal to the gradients of a, b, and c, d where they intersect. So we have f of x equals ax squared plus bx plus c. Our idea is that we don't know a, b, or c. When we have 3 unknowns, we need 3 equations. So keeping that in mind, this is a system of equations. So our goal here, when we notice that something is a system of equations situation, is that we need to gather as much information as possible about this situation to create as many equations as possible. We need to find a bunch of relationships, figure out where the puzzles are, where are these connections made. So we need to look at first the hint that it gave us here that says assume that the gradients of f of x, so our parabola, must be equal to the gradients of those lines where they intersect, which is what I said earlier. That since the gradient of AB is 3, then that means that the gradient of the tangent line, the slope of the tangent line at B, is also 3. So it says, hey, keep that in mind, which is a breadcrumb. Why would they say hey, keep in mind that at the point B, the gradient is 3? Hopefully, some thoughts here and some connections. At the point B, which is 2, 6, the slope is 3. We can assume that at point D, it's also -3, but let's just go with this for a second. We have this information. The slope is 3, which means we need to find the derivative, right? If we want to talk about a slope of a curve, we should talk about the derivative. So if I find the derivative of f of x for right now, that's 2ax plus b. Okay, so the derivative is equal to 3. And I have my first equation. Now I've eliminated c as an unknown, right? We will have to find it eventually, but right now I have an unknown that just, or have two unknowns that just involve a and b, which means if I got a second equation that only had a and b, I would then have enough equations to solve for a and b, and then I can go back in and see if I can figure out a few other things to solve for c. If I'm left with only one unknown, then things start to get easier. So if I can create more that have just A and B, then that would be great. So now is the time when we take a step back and say, okay, I need another relationship. I need another equation that sets up a relationship between A and B. Because then if I have two, I can solve for these two unknowns. We were given earlier that our line of symmetry is equal to 4. If you look in your formula packet, right? So if you're trying to make these connections and you're like, ooh, axis of symmetry, what's going on? Go look at your parabola formulas in your formula packet and notice that it does give you an axis of symmetry formula. Remember that your axis of symmetry is equal to negative b over 2a, right? The x value of your vertex is where your axis of symmetry is. So that involves b and a, and we know that it's equal to 4. It gave it to us. So what if we use that? Okay. Axis of symmetry equals 4, which equals negative b over 2a. Taking that, I could do 8a equals negative b. I could do b equals negative 8a and then substitute in, but all of that to say, I now have 2 equations that came from different information that involve a and b that I can put together. If you put in 2, 6 and 6, 6 into this equation and said, hey, 6 equals a times 2 squared plus b times 2 plus c, and then you did it again with point D, 6, 6, 6 equals a times 6 squared plus b times 6 plus c, you would have gotten 2 more equations as well that involved c, and you would have then had 3 equations. However, there are some points that don't help us here in regards to making a system of equations. So just be aware that since these guys are symmetric across the axis of symmetry, it actually doesn't help us because we'll have it all be set equal to 6. Let me show you what I mean. If I took the points that were given up above, and plugged them into this equation. So using b, that would be 6 equals 2 squared is 4 plus 2 times b plus c. We could also use this guy and say, okay, well then 6 equals 6 squared is 36a plus 6b plus c. Because these points are symmetric across our axis of symmetry, and they're set equal to 6 because of that, they have the same y value when it's symmetric across the axis of symmetry, it actually ends up giving you a value that's like, gives you an answer that it's like C could be anything, because it's not enough information to know about this specific guy, because you could have C, you could have this parabola be super tall, right? Or maybe even a little bit shorter. Realize that symmetric points across an axis of symmetry could create an infinite number of parabolas. So your axis of symmetry with 2 points that are symmetric is not enough information to create 3 systems of equations. 3 equations for your system. So we had to think about it in a different way. And notice that this hint, this breadcrumb, led you in the way that you needed to think about it. It said, hey, notice that at point B, it has the same slope as what we already asked you to find earlier. So listen to those breadcrumbs, listen to those hints, and say, okay, it tells me that I need to pay attention to the fact that the slope is the same there. Okay, what does that mean with slope? Well, that means derivative. Okay, let's see what happens when I start making derivatives and figure it out. You get enough equations to solve for A and B. Remember that your calculator has a system of equations, TI-84s. If you go to your apps, there should be a simultaneous equation solver. TI-80 or TI-Nspires menu. Remember that algebra is like all of the things that are helpful and do the algebra for you. Numerical solve, super helpful. Solve systems of equations, which we are going to use here. Also polynomial tools if you want to find your roots, right? So menu algebra. Algebra is where it like does the algebra for you. So we're going to do systems of equations because these are systems of equations. I'm going to do 2, but I want to do A and B just because I like to stay consistent with that. So that's 3 equals 4A plus B. I can also do this by hand. If you feel comfortable in that and you're like, can I just done it by hand? Absolutely. You could totally just do it by hand. It gave it to me as a decimal. I didn't like it, so I put it into a fraction instead. We get that A is equal to negative 3/4. And we get that B is equal to 6. Okay. So we have solved for 2 of our equations, or 2 of our unknowns. We now need to solve for the third unknown. And that means that we need to reference back to our not derivative, our original. So now we have that f of x is equal to negative 3/4 x squared plus 6 times x plus c. Here is where it would be a good idea to plug in one of your points that you have, whether it's 2, 6, or whether it's 6, 6, and then you can solve for c. I'm going to grab 2, 6 and solve for c in that way. Go ahead and solve for c on your own. We get that negative 3 is equal to c. And that's our answer. It does say find the values of a, b, and c, so leaving it as a, b, c equals is totally fine. I think it's also cool to go back and be like, oh, so the equation of this parabola is that. But you don't have to do that because it just asks you to solve for a, b, and c. Perfect. Good job today. That's it.